Roman, the discussion that's always hard to have on chat this morning about the data structure to replace the curve bag. Are you there?
Yeah.
Okay, great. I realised that we don't need as complex a structure as we had in the past because we no longer have a requirement to select tasks by content name because we don't ever do that anymore because we're now iterating through the entire bag contents on every access. We never have to go in and find one by name. So the only requirement we have is to maintain a sorted structure so that we can remove the lowest priority when we add a new entry, plus the ability to select items by an index. That is all we need. Now, the obvious thing to do that with is a sorted array. I mean, that is kind of the obvious structure for that, but it doesn't naturally fit within closure.
I don't see how is it obvious in this case. So my concern is that we have to sort this data by priority, but we need to select it by index. So anyway, we need two data structures there combined. So one for the sorting and another for selection. Anyway, we need to have some index because we'll use some kind of tree for sorting, but any kind of tree is bad for selection.
I agree. But I mean, the way I would do this in an immutable system would be I would just use a red-black tree. Which would automatically be indexed and I could find the lowest value very easily. But there isn't an easy way of doing that in a functional language, as far as I'm aware.
We have red-black tree in Clojure, and it is easy to get elements with lowest or highest priority. But anyway, with red-black tree, it will be a problem to get element by index.
Yeah, that's always the problem. That's why it's always been a real horrendous issue creating this building data structure. Okay.
So
we probably need
just
a session on this at some point.
Sorted maps, sorted sets in Clojure are red-black balanced trees.
So it's sorted sets and maps are what?
Red-black balanced trees. I don't remember how it is correct in English.
Oh yeah, okay, yeah. Actually, I think I did read about that. I think they are red-black trees. Actually, yeah, I think you're right. But I don't think they don't provide an index.
No, of course not, because it is not requirement for trees.
Yeah, I mean, well, you can get some versions that will allow you to access them by index.
Anyway, you have to build this index separate to tree. It is another data structure, just to make some fast access to data to elements. But to maintain this on when you will add new elements to this tree, you will have to maintain this index, and this is a problem.
Yeah, I agree. It's a problem. Okay, we'll talk about that. Patrick's here now, so we can have another session on that at some point.
Okay.
Welcome, Patrick.
Yeah, thank you. Yeah.
So the goal for this session was to begin the final walkthrough of the actors to make sure everybody was comfortable with where we're at and that we haven't missed anything. I think it probably makes sense to update you before we start on the final piece of the puzzle, which we put in place today with Pay, which was the final details about the forgetting. So if we just spend 5 minutes on that, then we can go into the actors. Is that okay with everybody?
Yep.
Yes.
Is there anything else anybody wants to cover off? No. Okay, great. So to make this simple, I will just copy the email onto the screen. Right. Can you see that okay on the screen?
Yeah.
Mm-hmm.
Great. So the idea here is we need a second dimension to the concept budget. At the moment, we had a single dimension value called activation, but Pay has come back with some valid concerns that we need to have a way of determining the quality as well, so that you're not just deleting low priority, because actually you could be deleting something that's currently low priority but is actually quite important to the system longer term. So we need a way of determining long-term quality of an item and delete based on its overall contribution, not its current moment contribution. So we're calling that term quality at the moment. The way we've looked at that is there's several possible derivations of that. Initially, we've gone with a relatively straightforward approach, and we use the actual priority values of the tasks. So if you recall, the way we calculate activation for a concept is we OR the priority values of all the tasks currently in the task bag. So that gives us a value between 0 and 1, and that's the current priority of the concept. And I won't use activation anymore because it's a double term now. It's now priority and quality. It's reverting back to its budget form. So I'll talk about it as budget instead of activation. So a concept has priority based on the OR of the priorities of all the contained tasks, and a quality, which at this stage, we're initially suggesting it begins at 0, but I'm not 100% sure that's right. We may want to start it at 0.5, in fact, but we can talk about that. So the idea of quality. Sorry, say again, Patrick.
I think it doesn't matter if we don't mix priority with quality. If we only delete the worst quality item, then it doesn't matter what the range is.
Okay, I've got some views on that, but we can come back to the detail. If we assume for now that quality begins at 0, so the idea here is that we've got this concept of difference, which is the new priority after a task has entered the concept versus the previous priority. And you subtract one from the other and you get a delta between the two. It could be positive, it could be negative. If the priority of the new one has gone up, then it'll be positive. If the priority new has gone down, it'll be negative. And quality is simply the previous priority plus the difference times the scaling factor. So it can either go up or it can go down. The other subtle difference here is that
I don't agree.
Don't agree what?
This should be
Oh, sorry, you're right. Should be the old quality, not the old priority. Yeah, typo. Yeah, thank you. Yeah, good point. The old quality, that's what happens when you're trying to type too fast. Yeah, so where it says priority here, that should in fact say quality. So the old quality plus the difference times the scaling factor. If it's a positive difference, we have one scaling factor. If it's a negative difference, we have a different scaling factor. And the reason for the different scaling factors is that we want to decrease it slower than we want to increase it, so that we don't suddenly find that a priority that hasn't been used for a long time, it has a very low quality, even though it's actually quite important long term. So the idea is to slowly change those quality values. It can increase faster than it can decrease. If there is no difference in the if the difference is 0, then the old quality just stays constant. So are there any questions on that particular aspect before I explain how it's used? Okay, cool. It's pretty. Oh, go on.
Additionally, we would need this max.
Yeah,
New.
yeah, that's fine. Just to keep it within bounds, yeah.
Right. This is
And then
everything.
this gets used in the concept forgetting collator, so that it essentially orders the selected concepts by quality and deletes the lowest quality items. We may actually want to use a combination of quality and priority for that. The absolute fine detail, we can determine that. I actually think it's probably a combination of quality and priority that we're using there rather than one or the other. But that's we can play with that, and it's not a hard thing to modify. So that's really. Yeah.
Pardon, I did not get what you mean.
Oh, okay. So the idea here is that quality is used to determine whether or not
The
we're going
forgetting.
to for forgetting. Yes.
Mhm.
Yeah. But we may also want to include an aspect of priority as well. So if something is low quality but high priority, we probably want to keep it versus something that's low quality and low priority. Yeah.
Probably we should we should define a forgetting factor, which is just, for example, the average between priority and quality, for example.
Yeah, exactly. Yeah, it can be as simple as that. Yeah.
Right.
Okay, so that's pretty much where we were on that. The conversation progressed a little bit, and you guys have probably seen this on email, that in fact this quality metric can become more involved, which we'll discuss in detail at a later point, just to really set some expectations here that there's several factors that that Paige brought up, and in fact we discussed earlier today many of these ideas. I won't go into the detail, but just to put a placeholder in the fact that quality can evolve into something more complex than just based on the history of priority. So, for example, taking into account intention, extensional balance,
I just
etc.
wanted to add that a friend will join. Is this okay?
Yeah, sure.
Oh,
The open
okay.
sessions.
Okay.
Give him a
I
second. Right.
didn't want to interrupt you.
No, that's fine. Not a problem. Has he already joined? No, he
Not yet.
hasn't. No, he hasn't. Okay, that's fine.
Oh, you
Okay,
can
so
continue.
yeah, so that's essentially where we're at with the forgetting. We have a solution that will work. It's more effective than just priority alone, and we can evolve it based on some ideas that we have to make it even more effective as we move forward. So any issues, questions on that before we move on to the actors?
Oh, no.
Okay. My original plan here, because I didn't think Patrick was going to be available for the start of the session, was to go through the simpler actors, make sure they're solid before we went on to the more difficult ones. But maybe we just go by section. So in that case, what I suggest is we start with the perception action section, see how far we get, and if there's still time left, we'll move on from there. Is everybody comfortable with that?
Yes, sounds good.
Sure.
Okay, so there's actually only 3 actors in here, although there's 7 boxes. Just to deal with that to start with, the channels, not necessarily limited to 3, but they're just specified as 3. These are essentially perception sensors. They just provide sentences to the system from the perception system. The green box specifies that these sensors can be affected by system operators, but they're not necessarily actors, although they may be. The NARS's input is essentially just a text input window that allows a user to enter NARS's strings. Pei raised an interesting observation when he went through the design spec. he said, should there not be multiple input channels?
No,
Now,
not OpenNARS.
I've already built that into the design. That's what the source parameter is in the metadata. It specifies where the statement came from.
Oh,
So if I quickly skip down to that section, so we have it source. So source, it can come from a user. It can be derived, it can be a percept, it can come from a peer unit, a parent unit, or a child unit. But additionally, it's accompanied by a unique, well, basically by a GUID. So the GUID specifies a unique aspect to what that source is. So every system will have its own unique GUID. Every individual user session will have a unique GUID. So they're essentially channels as Pei specified them. But we don't need multiple channels at the front end, because all you need to do is determine that the task has a source, and that source is uniquely identified. So that serves the same purpose as multiple channels. In fact, what you could do here is you could have multiple users using the same channel, but still differentiate them. So that was to answer the question from Pei on that particular aspect. But there's no reason why you can't have more of these input boxes on different systems, all feeding into the sentence parser. It just takes the source ID that's provided at that point, and then that will define it. The reason that's a potential issue is the question Pei raised, which I'll raise now just so it's on the agenda. Do we allow, in fact, he phrased it, do we allow temporal inference between statements from different channels? In our system, it's not so easy to separate temporal and general inference. So I'd say, the question is, do we allow inference between statements from separate channels?
Yes, I guess we should allow it.
Yeah, my view was yes, because certainly people talk to several people at once, and you don't separate them. You can still process different people and different concepts at the same time. Women are much better than that at men, apparently, but it's the same idea. Okay, so for now, my assumption was the same as yours, Patrick. We should allow it. If it becomes an issue, we might need to find a way of dealing with that. I think my solution to a more complex set of channels is that you just give each channel its own NARS unit, and then that kind of solves that. And maybe there's a central one that they can all feed into.
I also think that Pei thought that it's an appealing option because he may still think in the temporal chainer way.
Yeah,
because
I
if
think you're
there's a
right.
temporal chainer, there could be different chainers for the different channels. And with our temporal concept, we don't need this.
Yeah, I agree. That's my intuition is that as well. So if we stick with that, so that's kind of this dotted blue line covered. The actual actors themselves, sentence parser. It's a very straightforward actor. In fact, let me go to the description for it, which is the easiest way of dealing with this. So the sentence parser accepts a string representation of an RC statement, and parsers a valid statement, or generates a parse error, and that's it. All we need is something that can parse a BNF representation of the grammar, which we already have. Error handling, we can output to the display, although there isn't a direct connection there. We can add that without a problem, or we can use the login function. So there's two options for that. On that as a general point, I realized after I put these in that we probably could use the logging function as the display system for the for the output of questions as well. I don't know whether people have a strong view about that, whether we use login or whether we have dedicated actors for displaying user answers.
No, I prefer just having it in the background, but I think it doesn't matter much.
Yeah, I agree. It's not a big issue.
Well, output should go back to wherever the input source came from, right?
Ultimately, yes. So if you've got multiple channels running, yeah, that's true. Which you can identify with the source.
Mm-hmm. Yeah.
Okay. Oh, and just on that point, talking about the source now, the GUID itself is what uniquely identifies the input source. It's possible that a task source can change, so it might come into the system as a percept and end up as a derived task. But the GUID will still point to the unique source. So even if it says it's a derived source, it will still have a derived source from the GUID that was its actual entry point into the system.
What? Imagine we would have two different tasks from two different sources. What would
Yeah,
be the idea, the ID of the derived task?
it would be its GUID.
What? No, I mean the idea of the derived task. From which parent does it inherit the ideas?
No. Oh, okay, but it doesn't. Oh, I see. You mean if you're combining two tasks in inference and they come in from different sources? That actually,
Right.
you're right. That is a good question. Yeah, I don't know.
Wasn't the serial number just a new generated GUID?
No, serial numbers, a long starting at 0, incrementing one at a time for each task. But that won't help you determine the source of anything. Only it's.
But why do we even need this ID? I never used such a thing.
No, but that's because there aren't 17 people using the system simultaneously.
So that you see that which input tasks came from which paper?
Yeah, exactly. Yeah.
Okay.
But for derived tasks, does it have any sense? I don't see what is the sense of these identifiers for derived tasks, which were derived using different sources. I mean, sources for concepts that were used for this, or beliefs.
Yeah, that's fine. But if you have two tasks coming from different users that are used in inference, who do you send the answer back to?
Okay, it is only important for task which come from input. Yes, and
Yes,
if it was question, we know from what exactly input it comes. We don't need to have this ID in after general inference. I mean, so for derived task, we don't need this ID because we will not send this information to user.
No, that's true. But it might get used in local inference as the answer to a question. Oh, but you're right. But the question itself.
Yes. Okay.
Yeah. Okay, we probably need to think about this a bit more, but we shouldn't get bogged down on how we handle multiple simultaneous users, because that's.
But I think
that's kind of
Roman is right, because the input question will then be an input task, and this input question, if this one knows its ID, it's sufficient. So the rest
I think you're right.
don't need it.
Yeah, I think you're right. Because it's only going to be an input. Actually, yes, because it's only going to be an input task that you're answering a user question for, isn't it? There won't be any other type of type. Yeah, you're right. And we'll know
But
that.
my personal opinion on this is to move away from the Narcissa channels as fast as possible anyway, so that we use, for example, natural language input, but this is still a bit in the future.
Yeah, I mean, that would be great. I agree. There's still going to have to be a channel of some format, whether it's NARCs or natural language or whatever. It's still a connection to a user
This is
that we
true.
have to communicate with. It's a different problem, but it's kind of the same problem as well. Okay, so sentence parser is very straightforward. I should mention a couple of things it doesn't do, just so that we're clear. It does literally only parse a sentence. It doesn't do tense conversion. It doesn't add IDs. It doesn't add occurrence times, anything like that. It only does the grammar parsing. Are there any questions on sentence parser?
Oh no. So the task creator adds this information, right?
Yeah. Okay, I mean, sentence parser is pretty straightforward. I mean, to be honest, it's kind of almost done. I mean, it actually works now. It uses the parser, it outputs sentences, so it's kind of pretty much complete. The only thing it's missing, I think, is the error handling, but that's pretty straightforward. Okay, task creator. Let's just remind ourselves explicitly what it does. Right, accepts a valid sentence or a derived sentence, sets the source property based on the origin, adds a serial number, and converts the tense to the occurrence time. Take two message types. You'll see that sentences can come from the perception sensors, it can come from the operator executor or the sentence parser. And it also has a derived sentence message as well. The reason it's different is just because it comes from a different source, so it can identify that the source of these messages happens to be derived. The rest are essentially input sentences. The steps: adding a serial number. Task creator maintains the serial number internally. It starts at 0 and just increments it by 1 every time it's used. Task creator is responsible for maintaining the system clock for the input cycle. So again, the occurrence time is directly available inside task creator. That gets updated based on whatever the tick frequency is for that. So that's kind of part of this unit. And then it converts any tensors that happen to be applied to the sentences to occurrence time. So if it's a past, present, or future, it will apply the appropriate conversion to occurrence time. So it's either in the past, present, or future occurrence time, based on the duration window as well, so that it's within that time period if it's a present tense. I mean, that's really all it does, and then it just adds the task wrapper around that, adds the default budgets to input sentences. Derived sentences will have one because they come from the deriver. They'll be part of the message, derived sentence message, not necessarily the sentence itself. But that data will come from the deriver control aspect, because that's where its parents are available. So they'll send the budget data for the derived sentences, and the new ones will just get default budgets. That's it. I mean, are there any questions about that?
Oh, one question about this task creator. Will not this actor be like a bottleneck, as we will send all new tasks to this actor? Isn't this a problem? Do you understand my question?
Yeah, no, I absolutely understand your question. It's a funnel point. It will be a I mean, I don't know. I mean, bottleneck kind of has a negative connotation, but it is a bottleneck in a way because all the sentences that flow through the system flow through it. They also flow through Task Dispatcher as well. So
if ever we will need to, I don't know, scale this somehow, do we have options?
We could place multiples.
No, it's not. You can't. It's not that easy because you need to manage a serial number.
Oh, I see.
Yeah.
Does the serial number have to increment? Well, I don't understand why.
Yes, it does. The serial number. Every task gets a new serial number because that's the evidence
But a
trail.
random number would also do it,
Yeah.
I guess.
Sorry, say again.
A random number would also do it.
A random number.
Well, a GUID of some sort, no?
Oh yes.
Well, okay, but in theory, yes. In practice, that's going to be horribly inefficient. If you think about this, right, evidence trails are made up of lists of serial numbers. So if you've got 15 GUIDs in an evidence trail that you're trying to match an intersecting evidence trail with something else, that's a pretty big task to carry out every time you want to see whether you can revise something.
But integer or by default, for example, 32 bits, so it doesn't make a difference if it's a small number or if it's a random generated sequence of 32 bits.
Okay, let's just think this through. So a GUID is it is actually a 64-bit number, isn't it? A GUID. I think,
but it's the same for 64.
yeah, I know. I'm just thinking about maybe you're right actually. Oh no, it's bigger than that. It's much bigger than that. Oh blimey, this is huge. How many bits is this? Well, off the top of my head, that's probably.
Why do you have such a big idea? We always used.
No, it's a GUID. That's what a GUID looks like.
Okay.
GUID's a 128-bit.
Yeah. That's not the same as a serial number. They're different things.
Oh, okay. But
yeah. No, a serial number is just a long. So as it says in here somewhere, yeah. Look, it's just an N64. So that's not a problem.
But it's the serial number which is incremented, isn't it?
Yes.
Right, and this one is a 64-bit integer, so we can equally just generate a random 64-bit.
But it has to be a random 64-bit that you haven't used already.
This one is usually not a problem.
What do you mean it's not?
What?
No, that's terrible. No, you can't do that. What, and hope it doesn't come up with the same number you've already picked?
Yeah,
no, you can't do that. That's awful. It's not guaranteed to be unique, is it, if you do that?
I mean, under the assumption of insufficient knowledge, we can't just increment forever anyway. So in the end, it doesn't.
Now, I know that does kind of worry me that at some point we run out of 64-bit numbers, but it is quite a long time. That's quite a few years away before we have to worry about that one.
It's not a hard problem. I think the low bits of the number can indicate the specific task creator, and the numbers can be stored for each task creator. The used numbers can be stored in the specific task creator, which are used.
Yeah, you're right. We can find a coding scheme to do that. I agree. It's not the end of the world. So yeah, we could do that. I'm not overly concerned that task creator will be that much of a bottleneck. It doesn't have to do a huge amount of work on every task. I think task dispatcher is more likely to be a bigger bottleneck because it has to create concepts, or it has to actually it doesn't have to create them, but it has to forward on the requests. So, I mean, yeah, we could create multiple task creators. And as Robert says, we could use a task creator code as part of the serial ID. So yeah, I mean, that is possible. So yeah, so to answer your question, Roman, if it becomes an issue, can create multiple versions.
Okay, nice. Thank you.
But not with random numbers. Okay. Any more questions on Task Creator?
Not now.
Okay, great. Let's just look at Operator Executor then. Wherever that is, must be the next page. Oh, where is it? There it is. Right. So the Operator Executor accepts an operation execution request message and a parameter list that applies to that operation request if there is one. The operator executor maintains a list of registered operators and executes the requested operator on receipt of the message, and applying the parameter list if any are sent. And it's also responsible for generating any proprioceptive responses related to that operator and sending that to the task creator. So essentially, when a concept executes an operator, that message gets sent to here. The list of operations available is stored within the operator executor. The request operation is executed with the supplied parameter list, and if that operation is defined to produce a feedback message, that message is sent as a sentence message to the task creator and fed back into the system. And it may be that that operator simultaneously affects things within the system that are marked with green boxes. So depending on what the operator is, it may have an introspective impact on anything marked with a green box. And that is kind of it. Any questions on that?
Nope.
Okay. So that is all of this box essentially. Are people happy to move on? All right, let's keep memory management for a minute. We'll do a simpler one. General inference cycle. There's only 2 actors in there, so it's fairly straightforward to get this one completed. The two actors, the general inferencer, which we'll deal with that one first. It receives a single message, which is a do inference message. In fact, let's just read the description as well. Right, so the actor is responsible for executing the deriver. There can be multiple instances of that actor, like we were talking about the task creator, so there could be several instances. This one will become a bottleneck in the system, almost certainly. So multiple instances can alleviate that. This actor essentially just receives a message, the do inference message, which has a task and belief pair. i.e. the parents, they will be the parents of any derived conclusions. It generates the derived derivations. It's responsible for applying any of the control aspects. So managing the occurrence times based on task type, task occurrence times and belief occurrence times, generating the budget, and then forwarding all that on to the task creator as a derived message. So really, there's this is pretty straightforward conceptually. There's obviously a lot of detail in there in terms of how the driver actually functions. It generates statements. Those statements get a budget attached based on the budget rules and the parents that have been passed in. And the occurrence times are modified based on the rules that we have defined to be applied to task and belief type pairs. And that all gets passed on to task creator. And that is essentially it. As I say, there can be several instances of the general inference running to reduce the bottleneck that's almost certainly going to occur there. That's pretty much it. Are there any questions anyone has? Let me just check note 5 to make sure I'm not missing anything exciting here. No, we've already said all that. So, all right, let's move on to active concept collator. Active concept collator. Right, each inference cycle, the active concept collator collates the active concepts, where an active concept is any concept which is priority level exceeds a dynamically defined threshold. It just sends a message to the active concept saying, I'm an active concept. The active concept collects all those, and each cycle it selects n of those concepts, whatever we define n to be, via a selection function. Now, the way we're thinking this is going to work is that every concept that gets sent to the collator goes into one of two bags. If it's a general concept, it goes in a general concept bag. If it's a temporal concept, it goes in a temporal concept bag. We then select from that bag n concepts probabilistically based on their priority. So the higher priority ones get a higher chance of being selected than the lower ones. Every time we select one, we take it out of the bag. And therefore, the bag is then its contents are different now, so it can never be selected again. So the chances are that it's again a higher probability one will be selected than a lower one, but there's still probabilities that lower ones will get selected. Bearing in mind that these are all above a predefined priority level anyway, so the range is not the full range of a priority. It's only above the threshold, which will change dynamically. At the end of that selection, each of those selected concepts is sent a message to say there's basically this, you're being requested to carry out an inference operation. Then those bags are emptied at the start of the next cycle. And that cycle runs on a clock tick, which we can set. It doesn't have to run at the same frequency as the input cycle. It can run a completely different one, typically slower than the input cycle. Have I missed anything that's said? No, I think I've said all of that. So just walking through that. When a concept hits an activation level, it sends the active concept message to the collator. It collates all of those. At the end of the cycle, when the tick arrives, it selects n concepts from the general concept bag and then n concepts from the temporal concept bag, sends an inference request message to each of those concepts, and then the concepts process those. And then it resets the bags. And that is really all the active concept collator does. Simple as that.
But I don't see is why you select n from the general and then n from the temporal.
Right.
Why is this necessary?
Because there might be too many active concepts.
This I get, but what I mean is that the temporal concept and the general concept could be ranked together in the same bag.
Oh, I see. Why are they separate?
Right. I'm not sure if it's better to separate them, but probably it's
There was
better
a
to have
reason.
them.
Let me
Probably
just,
it's better to have them in the same bag because, for example, if the system is currently more
oh,
concerned
yeah,
with
yeah, yeah. I know
changing,
why. The reason why, this is why here. In the case of temporal concepts, a concept's activation is projected to the current moment.
but this we can do.
Oh, we can do that and put it in the same bag. Yeah, that's true.
Right.
Actually, you're right. For some reason, I was assuming it needed to go in a different bag because of that, but it doesn't need to, does it? It can be the same bag.
Weren't we selecting pairs of temporal concepts by their projected current
Oh,
science?
yeah. Sorry, that's right. You're right. It does say that there. I skipped that bit. Yeah, that's the difference. It has to pick two temporal concepts for temporal inference.
I agree.
Yeah, that was why. I knew there was a reason. Thank you. Thanks, Jared. That was the reason why they had to be in separate bags. So we can pick
Okay, this is
two
a good
temporal
reason.
ones. Yeah, okay, great. Well spotted. God, see, I can't remember everything either. Okay. Right. Yeah, good catch. So any other questions relating to that?
No. Yes. Uh, the threshold for the active concept message. This
Yeah.
one is still not.
Yeah, I thought about that. I am going to cheat. I am going to use in fact, there's going to be two global atoms. Otherwise, it was going to be a nightmare to try and update the threshold inside of concepts. So I'm going to cheat. I'm going to have two atoms, one called activation threshold, one called forgetting threshold, and we will just update those two global values dynamically rather than try and.
Sorry, Tony. How do you see this in distributed system? I don't understand.
Yeah, I know. We can manage that. It can be part of the data grid. So it can be a value that's shared, just like the global concept dictionary is. All that happens is there's kind of a master copy somewhere, and there's a replicated copy of it that gets passed around the nodes. So it's no more complex than it would be for any other data grid item. I say it's cheating. It's cheating from the sense that it's state that a concept uses that isn't actually held within the actor. But after some review of other models and things, in fact, it's not such a heinous crime. For example, Erlang, which is the definitive actor implementation, allows global tables and global databases to be used by actors. So it's not actually breaking any rules. As long as it doesn't become a normal way of working, it's fine. If it's a kind of an exceptional handling process, it's fine. And it simplifies the implementation massively, and it significantly improves the performance. So I think it's crazy not to do it that way.
The only thing which can happen, which is also the case for this global concept dictionary, that not all nodes have the most current values, but this doesn't matter that much because our system is relatively resistant. If, for example, a certain concept still has an old value of this threshold, it doesn't hurt much.
Yeah, you're right.
It's
It doesn't make much difference.
shortly
Right.
after,
Yeah.
it's relatively resistant against not having the newest value in all situations.
Yeah.
So it's not that big of an issue.
Okay, so that's kind of what I think probably makes sense as an approach to deal with that. At some point we need to manage that, and I'm glad you reminded me, because actually the active concept collator is going to have to be responsible for managing that value. So for example, if we've got this global atom which we'll call activation threshold, if active concept collator wants to select n concepts from the bag, but there aren't n there, it basically means the threshold is set too high. So it has to reduce it.
This is nice.
Yeah, and we may actually want to be slightly smarter than that. We don't want to necessarily run out of concepts. So what we might say is if there's, if there's not n plus 50, for example, concepts available, then you want to increase it. But we can work out the tuning of that. But the idea is to tune that parameter so we always have as many as n concepts to select from. And on the same process, whilst we're talking about this dynamic, the same thing for forgetting, will adjust the forgetting threshold in a similar manner. If there's not enough, actually, I don't think, actually, it probably doesn't apply anymore. We changed that one differently. So when we get to that one, I think it probably isn't required, that one, because we've changed how we're handling forgetting. So ignore that bit. But the activation level, we can handle in that way.
But why is it different in the forgetting case? We also need to decide
because if you remember, we're going to process them. We're processing them one at a time now. So all we do is we just forget the. Oh, I see. Because we've got this forgettable concept message, haven't we? Still.
Right.
Yeah, you're right. Okay, yes, you're right. Yeah, we do. It's the same. Yeah, we've changed things so many times I can't remember where we are. I'm glad we're having this review because I don't know what's going on.
Me either.
Okay, so let's just wrap up general inference then. So any other questions on general inference?
Oh no.
Nope.
Okay, let's move into the heart of the system, really, which is the concepts and the memory management. Let's start with task dispatcher, which actually is actually a very straightforward actor now. It just receives tasks. It checks. And there's two aspects to this. Now, I have an assumption here that in the metadata for task state, back up, we have this in each task, which is a list of subterms included in the statement, down to the level, like, for example, the third recursive depth level, based on what the meta rules require for processing, i.e. to create the subterm. So these will be the subterms of a task. It's set at 3 currently, but that's just going to be a system parameter because we may want to change at some point the depth that rules work to. So if we wanted to change it to 4, then we would need to change this to 4 as well. So a task.
This is the depth of term length?
Yes.
Okay.
Yeah.
Makes sense.
Essentially, yeah. So it's carried around with the task, and then we can use it.
Can I ask a question? What can be the reason for us to change this value to 4? Or I don't know. Other.
Well, it may be that we create some new inference rules that can work with 4 levels of data instead of the 3 that we have now. I don't know what they are. I just don't want to close off possibilities if it's any needs us to have just one simple parameter to modify that.
Actually, as I remember, for now we don't need this 3 levels for rules that don't contain conjunction. So
this is true. The 3rd level is only needed for in case that there's a conjunction in it. So far.
yes.
Okay, I don't have a problem with there being less. If we can find a way of doing that so it's smart, only stores what it needs to, then that's fine.
Okay.
Right.
Thanks.
Yeah, it doesn't have to be any more than we need. So if the nature of the task only requires 1 level, then only store 1 level.
No, I see. I thought maybe there is another reason for this.
No, nothing.
Okay.
It's only to support the inference rules, and if it's not required, then we don't need it.
Okay.
Yeah. I mean, directly related to that, it is what we use to create the sub concepts, but we only create those sub concepts to support the inference rules. So it's kind of it's a directly equivalent process. So when a task arrives here, it extracts that list plus its own content, and then checks, is there a concept for the content, and is there a concept for each of the items in the list? If any of them are missing, it sends the task to the concept creator. And we'll talk about concept creator in a minute. If they all exist, it simply dispatches the task to each of those items. So the statement's content and any of the items in the list, it just dispatches the task to all of those concepts. And that's it. And it does that by looking up the term reference in the concept dictionary, getting the actor ID, and sending the message, the task message to that actor ID. And that's it. That's all it does. Nothing else.
Mm-hmm.
Any questions about Task Dispatcher?
Not now.
Okay. Actually, I have noticed one error. This green box shouldn't be here anymore. It should be up here now. When we changed this system round, this was valid, but it shouldn't be here now. The reason this green box should be up here is that it allows the system to change the proportion of derived tasks to input tasks. So it can become more introspective or more focused under a null9 operator, which it doesn't work with it in Task Dispatcher anymore, because we used to derive tasks you tell me here, but we changed it. So that's just an error. It should be up there.
Because we decide the budget here, right?
Well, it isn't. It's not about budget. It's more about. Well, actually, yeah. I suppose. It could be budget as well. You're right. It could. You could do it with budget. That's another way of doing it. Yes. Yeah. So yes. So that green box will affect how Task Creator works. And this can't do that anymore. So I'll move that. Concept Creator. Pretty straightforward. Let me just read the text. I think I forgot to do that last time, but right. So concept creator responsible for creating new concepts based on the task message. So it creates the subterms along with the task content terms, propagates a budget to each of those, and the tasks. Sorry, not the task. Hang on. Blah, 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 blah. Get propagated by Task Dispatcher. So subterm, right, creates the subterm concepts and the content concept, sets the budgets. Right, and then once the concepts are created, task messages pass back to Task Dispatcher for processing. Now the concepts exist. Additionally, Concept Creator is responsible for creating the temporal concepts for input events. Oh yeah, good point. So let me just go back here. So there's two things going on here. So it's not just the content of the task or the subterm list, but also the occurrence time as well. That's also checked as a valid concept. The process is exactly the same. So the occurrence time is just a term. It will be in the concept dictionary, and if there is a matching term for it, that term will exist. So there's no difference.
Yes.
Yeah, it just does the same thing. Concept Creator, again, will do exactly the same thing. So it will check the content, the subterms, and the occurrence time and create all those concepts if they don't exist. And the last note on here was, about forgetting. So the concept creator maintains a count of the number of concepts created. And once that limit is reached, it sends a free memory message to the forgettable concept creator, which basically means I need you to free some memory because we haven't got, we've run out of concept space. And the way that happens is literally it just sends a message, free memory message. I didn't want to call it delete concept because that sounds like you were specifying a concept delete, which isn't actually what's happening. All it's saying is that we need to make some space, and you need to do that. So the forgettable concept creator is responsible for that, which we'll deal with next. But let's just make sure there aren't any questions around concept creator before we move on. Any questions or anyone have anything they don't understand around concept creator?
Yeah, the same question as previous time. Maybe we'll call this actor, like Patrick said last time, concept manager, not creator. If it sends this free memory message, it is.
Yeah, I mean, to be honest, I think we probably should consider these things a kind of a match pair. So if you're going to create, oh, actually, no, it wasn't. It was this one, wasn't it? Yeah, ignore that. This is kind of an odd one. The reason I'm inquiring about that is because the more of these concept creators you create, the more lock-in issues you're going to have with the concept dictionary. So I don't know how much performance gain you're going to get, because for every extra one of these you create, you're doubling the potential lock issues on the table.
I'm not sure if this is really a lock dictionary, because in distributed systems, it's often they often work under the assumption that it's not necessary for the distributed components to have the newest data in all circumstances. So it might be that it's anyway. It could be that the actor doesn't have the newest value in all situations, but it doesn't. It won't hurt.
Yeah, true. I mean, it's not a huge issue in our case, is it?
I actually said just about the name of the concept. Maybe you didn't understand me.
Oh, sorry. Maybe I didn't.
That it's
Maybe I didn't.
concept manager.
Yes, about this. This actor creates new concepts, but actually it sends the message to forgettable concept letters that we need to remove some concepts or other data. So maybe it is not.
Yeah.
Right.
Just thoughts.
Yeah. No, I understand what you're saying, and I kind of like it in one sense and not in another. The only thing it really does, it creates concepts, and when it hits its limit of concepts, it basically sends a message. Now, if this message actually said concept limit reached, this would probably be fine, because all it does, it creates concepts, and then when it hits a limit, it says concept limit reached. It doesn't really do anything more than that.
Okay.
Mm-hmm. Except that probably if it has reached it, it should not do this anymore, because then it can just skip it, for example.
No. It creates it, still creates a concept, because that concept is required, but it simultaneously says we have to delete one as well.
So it assumes that this one will then fastly enough forget.
Yeah, I mean it's kind of a it's a one-on-one. It sends it a message, forget a concept. I mean I don't think it's, because it's gonna do it as soon as it receives the message. It's not working on a clock or anything. So as soon as it gets the message to free memory, it's going to free a concept. I mean if we go over by 2 or 3 concepts, I don't see that as a huge issue.
I agree. Probably it's better this way anyway, because else we miss potential new concepts.
Yeah, exactly. I thought it was more important to process the task than worry about exceeding the limit by a small margin.
I agree.
Okay, great. But I just following on what I thought you were saying, Raz, was what you end up here about multiple instances of task creator. I think we could create multiple instances if we needed to as well. So I called you Razum again, didn't I? Oh, I'm going to slap myself now.
No problem.
Right.
Yeah.
Oh, it's not been so good. Okay. So that's concept creator. So before we move on to forgetting, any more questions around that?
Nope.
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 Okay, good. Forgettable concept collator. It depends on concepts sending a message to say they are forgettable. Now, if we go to the concept diagram, what you'll see is that whenever a task arrives at a concept, the first thing it does, it updates its budgets and activation level. Now, what we can do at this point is we can detect if or we can detect what the new budget is, and if the budget drops below the forgettable activation level, we send a message, i.e., this one, that says this concept is forgettable. All right, so that's.
This time the threshold is more interesting than in the concept collator, because in the general inference we know how much concepts we expect for a selection, and so we can naturally create a tendency for the system to use to adjust this threshold. But for the forgetting, it's probably a bit more tricky. I'm not sure yet how this.
I would actually say it's the same process. Let me read what I wrote about it, because I might have already solved this problem. Right. So when a concept's activation level falls below a dynamically specified threshold, it sends a forgettable concept message to the collator. Right. These are stored in a priority queue, where the lowest activation level is selected as the top of queue. When the actor receives a free memory message, it selects the top of queue for deletion. And then some additional stuff here. So a count of free memory messages is maintained to ensure there's always a deletion for each message received. Okay.
Okay. This is nice.
Yeah.
One question. What about my question? I mean, that I asked a week ago about how we will remove concepts that don't receive any messages.
Right. Yeah, and that's actually not an issue, because in here we always set forgettable concept when it falls below the threshold. So when a task message comes in, we check what the threshold is. And if it's fallen below the threshold, we send the message at that point.
Oh yes, I see. But what if we don't receive any messages? We had this discussion a week ago.
Yeah, you're right. I agree. If it doesn't receive a message, then it hasn't fallen below the threshold.
And it means that we will not remove this concept.
Well,
right.
no. Well, the thing is, it's messages that it's caught early, so every concept will receive messages at some point. And at some point, a message will either keep it above the threshold, or that message will put it below the threshold. If it's above the threshold and it doesn't receive any more messages, it's not a problem.
Then it won't be forgot, right? And shouldn't also.
Yeah. The only issue here is if
when the threshold changes.
if we change the threshold, that's right. If we change the threshold, and that that's true actually, isn't it? You're right. If the
Okay,
threshold
and
changes,
another problem. You said that there is some counter of these messages. Yes.
yes.
So that means that if concept sends these messages more frequently, we will remove this concept first. Yes.
No, sorry, not that message. It's the message from. Oh, there we go. It's the free messages. So it's this one here. It's going to maintain a count of how many things have to be freed.
I see. Okay.
Yeah. So if it doesn't have any to free at the moment, it will remember that. So when there's more forgettable concepts come in the next cycle, then it will then remember it's got to get rid of 3 concepts, and we'll get rid of 3 concepts.
Okay.
Yeah. So
but I still don't see how we will remove concepts that don't receive messages for a long period of time. Maybe it is not a big problem for us. Maybe all concepts will receive messages, but
okay.
Probably we need this threshold change message, but I think it's not a big problem because it just means that the concept isn't that it might have an out that how should I say, that its last evaluation on whether it was above or below the threshold is not really up to date anymore. And to some extent, it's really a problem. Probably we need this message.
and that means that we will not delete this concept.
Oh, if this message, it's gone.
The thing is, Roman, that if a task doesn't receive a message, then its priority is whatever it was set at. Based on it will have always received a message. It can't exist without having received a message.
This but Roman means if the threshold changes. If, for example, the threshold goes, if since the concept received a task, if in the meanwhile the threshold increased, then the concept will not recognize that it is itself below the threshold.
No, I agree. No, I accept that's a whole. Yeah.
So probably we need this a change message if the threshold changes too much. Then the concepts are updated.
We can't do that. See, it still won't help because it still won't get. Oh, I suppose that is a message in its own right, isn't it? It could use the change message itself to test the actual. Yeah. There's too many concepts though. We can't send millions of concepts.
I agree.
Oh bugger! I thought we'd solved this problem, but now that we've introduced this changing threshold, it becomes more problematic.
Where was it?
I mean, it was solved until we put that in. Maybe we should just take that out. Oh dear.
It's not.
Okay, let me just make sure Roman understands it. If we don't have that variable threshold, just a fixed threshold, do you understand why this works as it is? It can't ever produce a concept that won't get deleted. Or can you not see that yet?
Do you ask me?
Yes. Okay, let me explain it just to be clear. So every time a concept always receives a task. It has to have at least one. And whenever it receives a task, the priority is checked against the forgetting threshold.
Yes.
If it's below that threshold, it will send a forget me message.
It's clear.
Okay, so it can never sit around waiting to be deleted if it's below the threshold, because it would have had the message sent. The issue comes if that threshold changes. So this is a new problem. The new problem is if the threshold increases beyond the current priority level and it doesn't get any more messages, then it will just sit there without doing anything.
Yes, I understand this, but even if this threshold is not changed, this concept isn't used by system. It doesn't receive new messages, so we don't need this concept with great possibility. We can remove it, but we don't do this because it doesn't receive messages.
No, but it's received a message.
Yes,
Whenever
it received once task message, yes, but
right.
after
Every time it receives a message, it checks to see if it's below the threshold.
Okay, I see this. I understand. I understood this a week ago. It's clear.
But it can't sit around doing nothing because.
Okay, nice. If you're sure about this, no problem.
No, but my point is, if it's below the threshold, it would have sent a forget me message, and it will be forgotten.
Yes, I
If it's
understand
above
this.
the threshold, it will be at some point. It will probably get selected, whereby that message will then update the threshold value again. Well, not the threshold, but the forgetting value. If it's below the threshold, at that point, it will send a forget me message. So it actually always processes its state in advance. It never sits around doing nothing, waiting for something to happen. It's already checked its state. The first thing it does, and then if it should be deleted, it's already sent the message saying delete me.
Look, Tony, it checks its state, yes, but it checks state for current moment. But if we don't, I will tell this again. If we don't do anything with this concept, if it doesn't receive any messages, I don't want to continue this because it's like going in cycle. So
I understand what you're saying. We only delete a concept when it's well, it's not just its priority, as we discussed at the start of this discussion, but for argument's sake, just because a concept sits around for a long time without being accessed, it's not a reason to delete it, right? If its priority is above the threshold, then we don't delete it. We just leave it there on the basis that at some point we want to use it. If a message arrives and it gets processed, and in fact it's kind of rubbish and it priority drops and below the threshold, then we delete it. But there will be a lot of concepts that sit around for long periods of time that never gets used. That's kind of the normal mode of operation. Their priorities are always set whenever they receive that first message.
It looks like we will remove concepts that are used, but we will not remove concepts that are doing nothing.
No, we will remove concepts whose priority drops below a threshold.
Yes, but we will see this only if the concepts will receive some messages. That means that we use these concepts in our system currently. But okay, I see your point, and we will see in future how it will work. I cannot argue because I don't know. Maybe it's fine.
I can show you why it's indeed fine. When the concept is created, it means there is an initial task message, at least an initial one. At this point, we have an initial priority of the concept, and by this, for example, if this is the threshold, then we know it should already send this. But if it's above it, then it can happen that it won't receive anything in the future. It could be that that the concept priority stays as it is, and it could be that in between the deletion threshold rises, and this is the only case which can happen, that the concept should eventually be forgot, but it does not notice it because there are no new messages.
I understand this, Patrick. I understand all these things, but okay, I still have concerns about this model, because it's possible to have a lot of these concepts that don't receive any messages, and they will be like just garbage in our memory. And
Correct. We at least need to find a way to eliminate the only case where this can happen, namely when the threshold rises. There's no other case where this can happen.
I don't know. I don't know it in my like imagination. It maybe can be a different kind of ways how we can use the system. So maybe we will add a lot of different concepts, and I don't know, in some. Okay, just forget about this for now. It is not a big problem. I understand your point, and that's all. Thank you.
Okay.
Okay.
But Donny, we really need to get rid of this issue.
Yeah.
What if the if the threshold indeed rises and the concept does not recognize it?
Yeah, I agree.
This we need to eliminate, because then it can really happen that the concept is not recognizing that it should be deleted, and this we can't accept.
Yeah, I think we may have to use a two-phase approach. I think it is kind of like my original idea of garbage collection, which we do a sweep through concepts, so that it basically, I don't know whether it's constant or what, but it's a sub process that just checks each concept one at a time, based on its priority, what the current thresholds are, etc. Because if it's sat there doing nothing, it's not got a queue of messages or anything, so it's not an issue. So we can literally just cycle through the concept dictionary as a background process, sending a message. I don't mean on a constant basis, but on a periodic basis, so that over a period of time we send a message to every concept. So literally a kind of a slow sweep, because it's only it's kind of a backup measure, isn't it, to catch those that have fallen through the cracks. So it's not the primary method, it's just a secondary method to make sure we haven't missed anything. So it doesn't need to be very frequent or very high workload. It can be quite a relatively slow process that just does a few concepts at a time and cycles through the whole concept base every so often.
And sends I see. And checks the forgetting.
Basically, yeah, just to check to see that the priority hasn't fallen below the threshold. Yeah, I mean, for any that it finds, it can just send the forgettable concept message again. It doesn't matter if it's already sent it. It doesn't really make any difference. It just goes into the collection. So that shouldn't be a problem. But we can fine tune that. I mean, does anybody have an alternative to that?
Not now.
Okay, so we have this idea. So we've got a primary forgetting mechanism, which essentially relies on the concept to send a forget me message when its priority falls below a threshold, the forgettable concept collator stores all those concepts in a queue. When it receives a free memory message, it deletes the top of queue for each free memory message it receives. If it runs out of concepts to delete, it updates the threshold for forgetting to make it easier to forget. It stores any free memory messages that come in until more concepts become available, and then deletes those concepts based on the number of free memory messages it received. So it should always be approximately equal to maximum number of concepts in the system. The secondary mechanism we spoke about, in the event that the forgetting threshold changes and goes above a concept's existing priority without it sending a forget me message, we will do a slow sweep through concepts as a background process, check in their priority levels against the forgetting threshold, and send a forget me message if we find one that that requires it. That's kind of the general approach at the moment.
Oh, yes, this at least works.
Okay. Everyone happy to move on to Persistence Manager before we do concepts?
Mm-hmm.
Yes.
Okay. Persistence Manager is pretty straightforward. This is there to allow us to have a copy of concept memory, concept state, so we can restore it to disk or from disk between system runs. It's straightforward in the sense that when you request a backup of the system, Persistence Manager iterates through the global concept collection, sends a concept state request message to each of those concepts, and awaits the state to be returned by that concept. That state is stored on disk with the ID, so it can be restored on a subsequent run back from disk. And that's kind of it, right? It's as simple as that, really. Does anyone have any questions around that?
No.
Okay, so that just leaves us with the fun part, the general concepts and temporal concepts. If I go to the page. Oh, go on, stop playing around. There we go. So the structure of a general concept, let's deal with the data structure first. It basically has a task bag, which just has tasks. And they're all types of tasks: beliefs, questions, goals, quests, and anticipation tasks. And a terminate bag, which has a term and the concept it links to, which is just actually an actor ID. And that is basically this concept data structure here. The rest of the concept state is a budget, an emotion level, which is based on satisfaction, and whether or not this concept is observable. And that is the concept state.
Where
Yeah,
is this? This
where is it?
durability?
Sorry, say again, it's what?
Where is this durability value in the concept budget? Or this one we shouldn't need anymore?
Yeah, I agree. We don't use it, but it was part of budget, so I put budget in there.
Oh, okay.
Trying to avoid having another structure, because we've got durability is used in tasks, but quality is used in concepts. If people think that's slightly confusing, we can change it to task budget and concept budget, so they've got different parameter names. That's definitely an option. So task budget is priority and durability. Concept budget is priority and quality.
Right.
Okay, that's why it was there, but I don't mind either way. It's whatever people's preferences really. So that's concept state. The overall processing of a concept actor is the messages arrive, which causes the update of budget and activation levels, which we've discussed. Responsible for local inference processing, which we can talk about in a minute. I won't go into all the details just yet. General inference request and belief requests. If we talk about local inference, roughly, task message comes in, it updates the concept budget, it's then processed in the local inference flowchart. There are no derived results from local inference. The only output from local inference is an operator execution request. And that's it. That's anything that it generates. Actually, it's not 100% correct. It may output an answer to a question or a request. And depending on whether we use a logger or we use a dedicated channel manager for that, may or may not require a separate message. I probably should put a message in there actually thinking about it. So the output of question answers should go to the display manager as well. But that's kind of all local inference does. For general inference, actually, there's one other bit going on here, which is we'll come to that in a minute. So general inference receives general inference message, goes to general inference request. What that does, goes to the concept data structure, selects a task and a term link. It sends a belief request message to the selected term link.
Don't we send one for each term link?
Yeah, we do. You're right. Sorry, it does. We do that now, don't we? Yes, I've forgotten about that. Thank you. So it sends it to all of them. Let me go back to the concept description. Make sure I did write that down. No. Okay. No, it doesn't say that. So thank you. I had forgotten that small detail. So you're right. So we don't select a term link anymore. We send a belief request to all of the term links. Yes, which makes life much simpler. So this is several belief request messages going to each of the term links, however many there are. When that belief request message arrives at the target concept, it selects a projected belief from the tasks bag, and then sends the do inference request onto the general inferencer with the task, which comes with the belief request as well. So it has the belief and the task. They get sent on to the inferencer. Now there's two other things that happen here. When we get a belief request, when we get a general inference request, we also need to update the term link strength.
This is true.
So we send a message back to the originator of the message to say that you need to update the term link strength, and this is the concept priority level that you should use. And the same way, when the message comes in, it has the strength. Sorry, it has the priority of the sending concept as well. So this concept can also update its own link strength for that particular link. But I've written all that down somewhere. Let me just find where that was. It's in the, let's have a look. Yeah, it's in here. So the way this works in detail, so we select end concepts from the active concept collection, right? Send the inference request message to each selected concept. reset the concept collection. Right. So each concept on receiving an inference request message does the following: selects a task from the task bag. Okay, this has changed slightly, so it doesn't select a term. It now selects all of them. Sends a belief request message to each of those concepts along with the selected task. The concept on receiving the belief request message sends an update budget message to the task concept with its activation level, so the link strength can be updated. It updates its own link strength for the task concept based on the activation level in the belief request message. Yeah, and then if the concept is active, then it ranks and projects the beliefs in the task bag to the task time, sends the best ranked belief, selects the best ranked belief, and then sends the do inference message with that selected task and belief to the general inferencer. Yeah, okay. So that's actually correct, other than the term links now go to all of them instead of just one. Okay.
There's one thing, let me see. Yeah, I see there's a little, I guess it's just a convention issue here. Because as we know, tasks can have a different term than the concept they are contained in. So what you mean is we send the update budget message to the concept.
Message. Yeah,
right.
Sorry. Yeah, I'll change that to the source concept as opposed to task, right?
Right.
Yeah, so it's wherever the task came from. Yeah.
I agree.
Okay, I'll just change that to make it clearer. I'm just making notes here as we're talking. Right. Okay. So that's the general inference cycle, and then the other piece of that, which is slightly tricky, is the processing selected questions and query variables, because we have to deal with the budget on those. So I think the easiest thing to do is just go through this here. So right, So the selection process is the same as for general inference, as described above, with one difference. When a selective question is selected as a task along with a belief, an additional function is executed, i.e. the choice rule for task belief pairs. Excuse me. So the choice rule checks to see if the selected belief is a match for the task question. If it is, and it is the best solution found so far, question task is updated with the belief as the best solution. If the question task source is from a user, then the answer is output. The budget of the task and belief is adjusted based on the quality of the solution, where the task budget is decreased and the belief budget is increased. And then, so we move on. So the choice rule is a separate function to normal inference rules and is contained within the concept. Yeah. So if a best solution is found, then the budget is updated and a belief update message is sent to the task concept where the task budget is updated. Right. So it's the same idea here as updating link strength, except it's actually updating the budget. So that was all. That was the end of that. Okay. What I think I will do actually to make this slightly clearer is have two different names for this update, because I think I've used the same one. Actually, it's on the main on here. Yeah, I've called it a budget update message, but this actually does two different things, and I think that may be confusing. It updates the link strength, but it also updates the task budget based on a question being answered or a quest being answered.
Mm-hmm.
I think I don't have the most up-to-date information. Wasn't there something coming from the general inferencer going back to the concept to update that? Wasn't there a message going backwards?
No, we said we didn't need that in the end, if you remember. What we
Oh, right.
decided to do was move the choice rule processing into the concept.
Ah, okay, I
Um,
missed that one. Thanks.
yeah. So the concept that's got the task and the belief processes that choice rule, but it has to update the budget of the task. So it has to send a message back to the concept the task came from, so that that task can get updated. i.e. its budget can get updated.
Okay, yeah, I see. Thank you.
Yeah. Okay. Right. Good. I'm glad I've got this written down because I wouldn't remember all this stuff. My memory is appalling. So that is the general inference piece of a general concept. Does anybody have any questions?
Nope.
Nope.
Good. So that just leaves temporal concepts. Nope. Right. Temporal concepts. So temporal concepts are similar but simpler. So the data structure of temporal concepts. Actually, I haven't updated this since our discussion yesterday. So
No, we don't need this one anymore, right?
we don't need the term links anymore. No, they've gone now. So all we have is beliefs. And the way this works is the inference, the active concept collator maintains a bag of temporal concepts. It selects 2 for each inference step.
Well, for for each n pair, right? So like.
Yeah. So unlike the general concept where a message is sent to one concept and it selects its target beliefs, for temporal concepts, the source and the target are both selected at the same point, i.e. from the temporal concept bag in the concept collator. And those two, at that point, we will select a belief from one concept and a belief from another concept. And that will become the belief pair that goes to the inferencer.
All right.
Did anyone have any questions on that? Because it's fairly new based on our discussions of yesterday.
But
So hold on. So there's 2 concepts that are selected, and then a belief from each one of those is selected. Is that?
Yeah.
How are they sent together to the general inferencer?
Right. So it's the same. The message is, so it's the do inference request message is sent to the general inferencer, and it's got a task and a belief in it, although they both happen to. It's just basically it's 2 beliefs, and then that just does normal inference. So it just yeah, I mean that's it. It just selects a belief from each one, and
so
sends
this
those
one,
as a pair. Yeah.
so this one is also a task bag.
Yeah.
Only containing belief events.
Actually, to be honest, I don't even think it needs to be that. Because we had that discussion about whether or not we needed to rank those. Let me just find. Where's this section on? No, I can't remember where that's gone. Let me. That's. Oh yeah, no, that. So in fact, yeah. So the ranking's done on the concepts because all of the beliefs are all for the current moment. So there's no point ranking them. Yeah. So it's just a bag. Yes, that's right. Yeah, so it's just a bag. Yeah, so we just select them based on priority out the bag.
Right. There's one additional thing where we need to take care of. If we go back to the diagram of the entire system.
Yep, I'll do that.
The task dispatcher, it doesn't only have to send, if there is an event task coming in, it has to send it to both the general concept, the term named concept, as well as the temporal concept.
Yes, but that's just one of its terms, yeah? Because the occurrence time of the task is one of its terms to send to.
Right.
Okay.
Right. And one additional thing, when we rank the selected belief for general inference, when we rank the task table, we have to make sure that we only include those entries which have the same term as the concept it is contained in. Do you know what I mean?
I understand what you're saying. I'm just trying to understand why that's an issue. No, I don't understand why. Sorry. Let me just think about this.
Can you go back to the concept?
Concept, yeah.
To the general concept. Where is it? Down here. These entries, they, sorry. These entries can have a different content than the concept.
Yeah.
And for general inference, we only need to select those beliefs which share the same content with the belief they were selected from. Remember, in the artisan we had a belief table, and the entries of this table had the same content as the concept the table was contained in.
Yeah.
Right.
Okay.
And the thing is, why is this important? This is a good question. The thing is, if we have, how should I say, we can't guarantee that the tasks which are contained here, we can't guarantee the semantic connectionship between the premises if we, but let's see if this is really the case. Probably I'm wrong. Let's say we have a concept. And let's say, of course, this concept, which is linked like this. And let's say we have Tim is a cat, which is also linked to this concept. And now here in the cat concept, we have two tasks. The first one being and right.
Yeah.
And now let me think 1 moment. If we the task cat animal would also be in this concept, of course,
Yeah.
and we would have just we have also the task dim cat in this concept.
But actually, as I understand, task cat animal can be in this concept too. I mean, team cat.
Pardon?
I mean, the task cat animal can be inside team cat concept, isn't?
No,
Oh no.
because
It can
it's
be.
not, the content's not the same and it's not a subterm.
Okay.
Yeah.
I see. Thank you. Mhm.
So before, if we wanted to derive this, we needed 2 things. In the org design, we selected this concept in inference, selected, for example, selected this task, selected this term link, selected this belief, and derived the result.
Yeah.
Another case which could happen, we select this concept, we select the second as task, we select the term link, we select the belief, and we derive the result.
Yeah.
Let's see what it would mean if we would eliminate this restriction. What would be the difference?
I don't think it
I
makes
see.
any difference.
I see there is a difference. It could happen. Let me see.
So if you pick cat as the task, then you can pick cat animal or Tim animal, and you pick one of the term links of cat. So you're either going to pick cat animal or Tim cat as the only 2 possible beliefs. Tim cat, cat animal. So you're either revising or deducing. They've both got, they'll have a common term. That's always going to have a common term. That's right. That's the bit I couldn't understand. Why you thought there might not be a common term.
No, this is not the thing I'm concerned about. I'm concerned about the semantic relationship. Whether the result really ends up in the red. Let's see. There's one difference. This is the new thing which can happen. Now it can happen that this one is selected as concept.
Yeah.
That this one is selected as task.
Yeah.
That this one is selected as term link.
Yeah.
And that we select a belief which does not directly relate to this concept. What is the consequence of this?
You mean it's the first premise? I don't understand. No, I understand what you're saying, that it's not directly related to the content, but it's still got a common term. So if you select Tim Cat and Cat Animal, you can still get Tim Animal.
I agree. I guess it's not an issue. Interesting.
So I never really understood the issue before about having to constrain the beliefs to that because I haven't ever worked that way. I couldn't quite see the problem, but I definitely don't see it in this particular case. Especially as we're selecting all the term links anyway, so they're all going to get an opportunity to be used.
Mm-hmm.
And there's always going to be a semantic relationship because it's always a subterm.
Mm-hmm. I agree. So the interesting thing, the difference to before is that this concept has the ability to activate this concept. Before, this was not possible.
Oh, yeah.
Before, only this concept was able to activate this concept.
So the order was important before, but it's not important now because it works either way.
Interesting.
Yeah.
I agree. I don't see why this activation would not be valid. Because because it's exactly inference which determines what can activate what.
Yeah.
And so in this case I don't see a problem. So probably we don't even need this restriction. Interesting.
Good. That was worth doing anyway.
Mm-hmm.
I can just clear that for you. Here we go.
No. Oh, okay.
Sorry.
Too late.
Another question.
It's really interesting that this concept can activate.
Okay.
No, to some extent it is strange. Because before it was exactly the common term concept, which was the one which was the only one which was able to activate. Now we certainly have the case where a concept which was not the common term can activate the target concept. And I'm not sure if this is good. I don't have a good counterexample yet, but it might be an issue.
Time to ask Pei.
Well, I'm not sure what we've done to change it though. Oh, it's because we're allowing it to select any belief as opposed to filter beliefs.
Right.
Yeah.
We allow it to select beliefs which content is not equal as the concept they lie in. They are in. And this is the difference which leads to the strange effect that the concept can activate another, although it is not the common subterm. It shares a common subterm, but it is not the concept
Common
of
subterm.
the
Yeah.
common subterm. And this is indeed a big difference.
Okay, we probably need to be careful with this one. We need to double check it.
Because one of the effects which it would have, let's say the concept cat is not important at all. Suddenly the other concept could be important and could derive the result out of itself is not the common subterm. I don't have a good counterexample yet, but I have to think about this.
Yeah, I think we do need to think about that one. I don't think we're going to do that right now because you need to sort of sit down with a pencil and paper and work through some examples. All right. Okay. That was kind of an issue that came up when we were talking about. Oh, we kind of at the end, hadn't we? So it was question marks really. Yeah. So were there any other questions or issues that anyone has spotted as we were going through there, or anything anyone needs to know?
Can we run? Oh, sorry. You go first.
It looks like we didn't say any word about anticipation.
Yeah, I was about
Today.
to raise that as well.
Oh, anticipation. Yeah. Sorry, we didn't go into the details of the local inference, did we?
No.
You're right. So so let me get as much of this. So we'll do the simple ones. So we do quest. Excuse me. So a quest task comes in, and well, essentially we rank it. So we rank the goals from by projecting to the task time. Then we select the highest confidence value or the desirability technically. But if we just for now assume that confidence equals desirability within desire value, then it's easier to talk about. So we select the highest confidence value of the projected goals. So that's the best one relating to the task time of the task that's coming in. And then we add that as a solution to the task on the basis that there is one. If there aren't any, then this step doesn't happen. But if there are goals, one of them is going to be the best one, and it will be the best solution for this task, because it won't have come in otherwise.
If it doesn't, it
should go
still
around.
Red.
Yeah. We update the budget based on the solution. If it was a user quest, we output the answer. If it wasn't, we add it to tasks, and that's it. I mean, that's as simple as that. So select the best ranked goal for the task time. If that exists, add it as a solution, update the budget. Otherwise, we get to here. If it's a user quest, we output the answer. Either way, we add the task, either the updated one or the original task if there wasn't anything to update it with, to the task bag. That's it. It's done. It's exactly the same process for questions, except we do it with beliefs instead of goals. Other than that, it's exactly the same. So any questions on either of those two?
No.
Nope.
Yeah, and the ranking, the detailed ranking equation is in the ranking and projection section. The formula's all there. You can read it, but it's all clearly defined. Oh, there was one change to that actually that Pay mentioned. Let me just bring that up quickly so it's clear for Patrick as well. Pay mentioned that this should be a scale complexity, not just a flat complexity. It was C before. He suggested it was a power function, so I've just added the scaling power function for C. Because actually, when you look in the book, in fact, it is actually scaled, and I'd forgotten about that as well. It probably means our implementation paper is wrong.
This also works, but in the art design it was just one, so it was just.
Was it? Oh, okay. Yeah,
red.
fair enough. So I guess if it was just one, it doesn't make any difference. Yeah, fair enough. Was there someone else asking a question in there? No. Okay. So that was the questions. Let's we'll deal with goals first because they're slightly simpler. Then we'll deal with the beliefs. So goals. So the process, goal task arrives. We select the best ranked belief from tasks and that's projected to the task time. So we're going to get one belief from the task bag after it's been projected to task time. And just a note on this: all of these require an iteration through the task bag. So you probably missed it earlier, Patrick, but there's no requirement for a task bag to be able to select a specific task by content anymore. We never need to do that. So it makes the task bag's semantics slightly simpler. We're always iterating through the entire bag collection.
Oh, now I see the. Oh. Let me think one moment. The only thing we really need to make sure about is that the same question, if it doesn't have query variables, that it can really only be answered inside one concept. Else we get inconsistencies between concepts, and this is exactly what the concepts try to resolve. See what I mean?
Yeah, if the question's in multiple places, it's
Right.
going to get different answers.
This should not happen. This we need to make sure. So it might really be that. Can it happen?
Yeah, it can, because the question can get sent to any of the subterm concepts along with any of the beliefs.
Right, and the beliefs. For example, okay, here it was just not that trivial. Here we saw cat animal. Damn. And this concept can never have a own, how should I say, there can't be a statement called cat. But in case of, for example, then it's already the case that this thing alone can have beliefs. So I guess we really need it, because else we end up with the problem that this question of this subterm can be answered differently in the concept. Sorry.
Yeah.
That it can be answered differently in the concept it comes from than it's answered in the sub concept. This we really need to make sure about, that this does not happen. So, is this already a case where this happens?
Okay, I'm just trying to understand the issue here. I mean, I understand what you're saying. The issue is we can potentially answer the same question in several concepts with different beliefs.
This should.
But the reality is they're all going to be the same beliefs, because they're all subterms of.
No, I don't agree. Task bags have different. For example, the concept cat can have different tasks, like tasks of cat animal or cat thing or cat object.
I don't mean the same as the content. I mean all the subterms, because the task dispatcher sends the task to the content name concept and all of the subterms, all the subconcepts. So they've all got the same belief in, and they'll all have the same question in.
I don't agree. There's a difference, because the task bags have a fixed size, and so the question.
Oh, that's true. Yeah.
So a certain belief which might be answered might not even exist anymore in the sub.
Yeah. They might have gone. Yeah. Okay. So the issue is that we can end up having conflicting answers to questions from different concepts.
And the same for decision making. It could be that different cores have different satisfaction in different sub-concepts, and this should not happen. This is
Yeah.
really something we need to make sure about that it doesn't happen.
Okay, but
But
that's an easy fix, isn't it? All we have to do is filter the ranking selection by
having the same content.
the same content as the concept.
Right.
Yeah.
And I guess this we really need to do because. But let me think. Half a minute. Yes, it's already a case where it happens. We need to do this in order to get rid of this problem.
Okay.
And so also the budget question is answered, because when we don't allow this, we also don't allow the activation coming from a concept which is not a common subterm.
Yeah.
So this one is also resolved by this.
Yeah. Okay. No, that's fine. And to be honest, it adds very little overhead because we're already iterating through the bag anyway. So we're already filtering the bag. So it's just a slightly more complicated filter, but only marginally.
I agree, and
Yeah.
it can be pre-caged, so it can be marked for a task that it has the same content as the concept it is stored in, so it doesn't have to
Yeah.
be re-evaluated all the
Yeah.
time.
Okay. Yeah, that's true.
Right. Oh yes.
Oh, good catch. Right.
Thank you.
That was worth doing just for that, wasn't it? Although actually it's an easy fix, so that's always nice. Okay, so let's go through the goals then. So goal task arrives. We rank the beliefs projected to task time, select the highest ranked one. We modify the budget, so we decrease the goal budget, increase the belief budget on the basis that there is a matching belief. If there isn't, we skip this step. We collate all the goals in the task bag by confidence projected to task time. We revise the task with all the revisable goals in the collated results, if there are any revisable goals. Okay, we add the task and the revised task to the task bag, if there is a revised task. Then we check to see if the revised task answers any outstanding quests. If the goal is an operation, we project the task at the current time. The task in this case is the goal. We then check the confidence is above the threshold for the decision function. If it is, we execute the revised goal, which essentially means we send the operation execution request message to the operator and executor actor. Otherwise, yep, go on.
There's one additional thing, because in the decision threshold part, because to some people it looks strange that the system may still execute something or if it is already satisfied. In principle, it would be valid if the where is it? Where's the satisfaction calculation? I think it's. Can you scroll up a bit?
Oh, sorry. Yeah.
Right. If the truth expectation of the belief in respect to the time of the core exceeds the truth expectation of the core, then it would principally be valid to not execute. You know what I mean?
Yeah. So if it's already attained the desired satisfaction level, there's no point executing it.
Right.
Yeah.
This would be a treatment which would also be valid, which we could add, because to some extent it's I mean, I'm sure it will work that we only reduce the priority because it won't spend time anymore on goals which are already satisfied. So this is in principle already valid, but I think we can add this additionally. So
I'm not sure. Is it possible for that to actually happen though? So if I'd have to work through some numbers, but if you're going to decrease the goal.
Priority, right? But
it's budget, isn't it? It's only budget, not confidence.
Right.
Sorry. Yes.
For example, if a core is processed with a very little priority, it would come out to have a very low priority, but it could still exceed the decision threshold. And so it may be better to add this, because then we know that the executions really are meaningful and not just to just to make something even truer or if it's already satisfied. So we can add this how should we write it?
Oh, hang on a second though. This is adjusting the budget on the basis that this will happen because it has been satisfied.
This, I mean, so if the belief growth expectation is already above the goal growth expectation, it doesn't really have to do it.
You're talking about but that's the values before we adjust them based on satisfaction. So that would be the original values.
No, what we adjust is the priority, the budget.
Oh yeah, sorry, you're right. Yeah, I said that before. You're right. Yeah. So that hasn't changed. You're right. Sorry, I keep making the same mistake. Right.
Right. I think we should add it because
No, I agree. It makes sense.
I mean, it would also work without this part, but it's better to have the executions really being necessary and not just as
You're right.
as a sign that the system has too much time.
Yeah.
Right.
Okay, great.
Okay.
Yeah. So that is goals. Anybody else have other questions on goals?
Not now, but I hope that all these details will be in the design documentation. I mean, about creations and other stuff.
Sorry, about what?
About things that were discussed 5 minutes ago.
Oh yeah. I've got notes for all those. Yeah. Okay, so then the last piece, which includes the anticipation tasks, is belief handling. So similar approach to goals. Select best ranked goal from tasks projected to task time. So basically, we're getting the highest confidence value goal. We're decreasing the budget of the goal, increasing the budget of the belief based on how satisfied that is. We collate all the beliefs in the task projected to task time. At this point, we do a check, which is related to the anticipation tasks. So if the input belief, so if the belief task is an input event, then we do the following. We collate all the anticipations from tasks projected to the task time, and we revise the task with all the anticipations in those collated results.
Mm-hmm.
So essentially that updates each anticipation task with a revision operation against that input event.
Mm-hmm. This is correct.
We then revise the task with all the revisable beliefs in the collated results. So this is now slightly changed in that we're only going to be doing this with the beliefs that match the content of the concept. So
Mm-hmm.
that's the filter on that, but yeah, but that's the same conceptual process.
Right.
We add the task and revise task to the task bag. Check to see if it answers any outstanding questions. Then more anticipation stuff. So for each expired anticipation task in the task bag, we generate basically a negative confirmation matching the event with a high priority and add it to the task bag. Now, the important thing to understand here is that every anticipation task always gets a negative confirmation generated, whether or not there was
this
actually.
Is also
Go on.
Because we want the anticipation result in the same concept, we should modulate the priority, the frequency dependent on the result. You know what I mean?
Yeah, absolutely. That's what I'm saying. There's always a.
So it should not be represented as this.
Well, this is the not truth function as opposed to the not.
I thought that A is the content of the task.
Yeah, sorry, you're right. I'll write this differently so it's clearer. But the idea is it's the not of the truth value that gets generated, rather than not the content.
But
no,
it's
both.
not.
It's both. It's both. So what are you saying? Go on.
But I mean, it's not a strict not. It's depending on where is it? It's depending on how much the anticipation was satisfied by the
Yes.
input, right?
Right.
So if it's, for example, highly satisfied, it will
Of a very lowly satisfied negative confirmation.
Right.
So if it's satisfied by 0.9, then it'll be a 0.1 negative confirmation, which is just not.
Right.
Yeah, that is all the not truth function does. It just subtracts it from 1. Yeah.
But I mean, it's right. It's just that our anticipation will expire, even those which were
Yeah, even those that are satisfied.
Right.
Yeah, absolutely. They all get one of these. They all get a negative confirmation, which is the difference between how well they were satisfied. So if something was fully satisfied, its confirmation would be 0, but that can never happen.
But there's a little issue here.
Oh, okay. What's the issue?
I didn't see it earlier. It's not a big issue, but it is an issue. Let's say the system predicts my favorite example, light on. And it predicts this. I'll write it down just for completeness. Then the system observes in which case the anticipation of the predicted event is highly satisfied, right? because of this observation.
Okay. It's satisfied to
Thing
whatever
is,
degree the truth of that is. Yeah.
all right, right. Let's say it's exactly the truth value it predicted, and
Right.
here we would have at some point the anticipation will expire, right?
Yep.
With the result. Uh, See the issue? We would have
No, but
it twice.
it's not going to be light on. It's going to be not light on.
I don't agree.
It's a negative confirmation.
No, it's not negative because it was observed.
But it wasn't fully observed. It was only partially observed.
No,
That's my point.
we said it was observed with the truth value of the prediction.
Yeah. Oh, of the prediction.
So it's the extreme case that the anticipation is fully satisfied.
Oh, I see. Okay, right. Yeah, that's
What
true.
we generate additional evidence, which we should probably not do.
No, but see, I didn't see this. Well, I was expecting this to actually be negative evidence for the observation, but in this case, because it's fully satisfied, the negative evidence is in fact zero. There is no evidence to say. So the not light on is the negative confirmation, but there's zero evidence of that because the observation was the prediction was fully satisfied. So it generates a negative confirmation. So not light on with truth value of, in this case, zero.
No. First thing, we can't allow this thing because we want the result to be in the same concept and not go through the general inference cycle. We want the result in the same concept, so we can only allow this term. This is the first thing.
Yeah, that's true. Yeah. Okay, fair enough. It's going to go into this one. Yes, fair enough.
The second thing is that such that this would be equal to let on. So even if it would be represented this way, the same issue would arise.
Yeah, okay.
Oh, can I ask a question? But if this task is satisfied, I mean anticipation task, why we cannot remove this task?
Because it's in most cases it is not even fully satisfied. For example, it is partly satisfied, or for example, to 90% satisfied, and we don't want to already remove it. And already, if we have 90%, this issue is already the case. And I think I just found a solution to this.
Cool.
But let me think one moment. The solution lies in the total evidence we've collected. If we, for example, let's say we collected by the observation confidence 0.9, and we predicted that amount of evidence 0.9. And the thing is, we should subtract the confidence the total evidence we already observed from this predicted. So in this case, we get confidence 0.9 minus 0.9 because we already observed the amount of evidence we predicted. This is the solution. This is the solution. Nice. So if we, for example, would only have observed this to a certain degree, for example 0.45, then we would modulate the confidence and the result would be this, with the half of the evidence.
Yeah. What about the frequency?
Something that I heard about this that scarred you for, I won't say your whole life, but your life thus far. I've been around 2 years, so yeah, I mean, those two.
I guess it's still not the answer.
Yeah. I'm just wondering if it's actually the same approach.
These last 2 years have been rough, I'll be honest.
Well, let's just think about this.
I think this is really a case where total evidence needs to be subtracted, because else
I agree with that. I agree with you completely there. That was kind of part of what I was thinking already. So I agree with that. I don't have any issues with that.
The frequency will already be the result of the revisions. We only need to make sure that what we do is really only subtracting total evidence.
Okay, well this isn't generating the negative confirmation that we had before in the previous system.
Yes, in case that it's not in the total case, in the extreme case that there is no observation of that input event, it would start with. It would of course start
sorry,
with
you're right.
with the negative.
The general inference will create the not based on the fact that there's no evidence. Yeah. Okay, sorry. Yes, I've been slow there. Yeah, I did know that. It just fell out one of many holes in my head. Yeah. Okay.
But here we need to make sure that we consider the amount of evidence we got by the observations.
Yeah.
Because if we know the amount of evidence, we don't have to. We are only allowed to. We are not allowed to put in the same amount of evidence, because then we would amplify the strength of our observation. But this is not what we want anticipation to do. It's not allowed to amplify our observation.
No, but that's okay, because the anticipation task will have revised all of the evidence, of all the new evidence as it comes in. So the selected anticipation task will be the best observation for the prediction. So I agree with the confidence handling. So yeah, prediction minus observation.
Right.
It's possible actually that you could end up with a higher observational confidence than the prediction.
This is also true. What would this mean?
Well, I guess it still means the prediction's wrong. But in a different way.
If the observation has a higher confidence.
By the way, can I ask another question? If you don't mind.
Sure.
Okay. Actually, it is the same question. It's about what if we as I understand, each time when we have new task, we check expired anticipation tasks. Is it correct or not?
Mm-hmm.
Yep.
Or what if we don't receive new tasks in this concept, inside this concept? So we don't do this check. So we don't check expired anticipation tasks.
No, that's correct. Nothing would happen if there's no further tasks arrive.
Mhm.
Then nothing happens.
And then once new tasks arrive and we send a lot of I don't know, new tasks with negation or something else, and it's fine. Yes, it's correct.
Yeah, I mean, if there's a big gap between the prediction and nothing happens for a while, then at some point in the future, you get another task. That all of those anticipation tasks will have expired, and then they will all get negative confirmations at some point in the future.
But maybe we need this to be done.
When it expires.
Yes.
Hmm.
I mean, more close to the time of expiration. Isn't this a problem?
Potentially.
Well, I don't think it is, because you're not going to do anything with the fact that that task has expired until you process the next task that arrives, at which point you will process the fact that it's expired.
But as I remember from previous version, we just check it each time for all concepts. As I remember, we had some.
Yeah, there was a basically an anticipation buffer
Mhm.
in the main
I have
input
the
flow.
solution. I have the solution. It's not that we have to subtract confidence. We have to make sure that that the uh, the result of the expiration, because the expiration is itself a revision of tasks, right?
Yep.
So what we have is that this expiration stamp contains the evidential base of this observation, with the result that although this is an extra task which gets derived, it will never be used to revise this and to form a stronger belief. This
True.
is the solution. We just have to make sure that the same principle we apply in all other inference, namely to track the premises in to track the evidential basis. We also have to do this at this point for the anticipations to know which observations were considered when we created the value for the expiration event. So all we have to do is that this observation is part of the evidential base.
But it is. It always was. The anticipation task has an evidence trail, which is what the revision updates.
If it does, then it's fine.
Yeah, you're
But
right. Actually,
it has to.
yeah, I'd forgotten that as well. So it can't be used twice, as you say, because it's already been used and the evidence trails will overlap, so it can't revise again. Yeah. Yeah.
So, right. So this is the solution. We don't need to subtract confidence. We just
Right.
need to make sure that we know which observations we used in order to derive this expiration event. Because then it won't use the expiration event together with the observation and the revision in order to come up with a stronger result. So,
Right. Yeah,
so,
absolutely.
so we don't have this issue of counting evidence twice.
Right.
We're just tracking.
Okay,
the
but
step.
we still have to convert the anticipated result into a negative confirmation.
To a degree, negative confirmation.
To a degree, yeah.
Right. We have to modulate the frequency according to the result of these revisions.
Right.
Right.
Which is why I thought the not frequency was going to be basically.
The revision already has the answer to what the resulting frequency is.
Yeah, no, I agree. I just want to make sure we're clear on precisely how we're going to modify that frequency. So
it's just revision. For example, if we have a b percent 0.5 and sorry, 0.1 and a b 0 revision a b. So revision already takes care of this.
Yeah, no, I get that bit. Sorry, but it's when we get to the expired event, we need to generate the negative confirmation.
This you mean? Yes, this is true. Because it's exactly the opposite of the confirmation, right?
Yeah,
the
so
disappointment.
This is what I'm saying. It's just, yeah, right.
I agree.
Okay.
This you meant. This is where you use the drop.
Yeah, sorry, it probably wasn't anywhere near clear enough. So if I put not F in there instead of not A. Right.
Red. Okay, so this is red. We
Okay,
have to use
good. So that just to catch on Roman's question there about if this doesn't get processed for a long time, those expired anticipations will be very old. So does that generate an issue for us? So if another task doesn't arrive, is there a problem? I don't think there is a problem personally. But I'm just kind of want to double check that.
Why we send this task when anticipation task expired? Why we send another this not task? Why we do this?
Yeah, so because it's not actually a not task. It's a not truth value. So the task is the same, but it basically inverts the truth value. So if the truth value of the anticipated task is 0.8, the not value of that will be 0.2.
Got
yeah.
it.
So that's basically saying that the task happened with a 0.8 probability, and it didn't happen with a 0.2 probability. So when we put the low frequency, high priority anticipation task or task into the task bag, it will get selected because it's high priority. When it goes through general inference, the 0.2 will get converted by the not inference rule into a 0.8 not happening. That's why we put it in the bag.
Okay, so and it will not be a problem for us to if you will not generate this new task.
It won't be because when you mean in terms of doing it now sort of thing as opposed to later. It doesn't matter because all these things are relative to their occurrence times. So if it happens much later, the budget will be significantly affected by the old occurrence time. Therefore, it will have a very low priority, and therefore it isn't going to have much impact on the system.
What's also the expired task occurrence time should be those of the prediction. This is an additional Did I?
I'm just thinking what it is at the moment. Where do we?
So the occurrence time of the expired event should not be so when it expired, but when the predicted event was expected.
Yeah. Well,
Right.
that is what the expected time is. So the expected expiry time is the expiry time defined when the anticipation is created to be when it was expected to expire. Yes, yeah. That is what it is. Yeah.
But the expiry time defined when it. So this is the prediction time?
So the expired equal is if the current time is greater than the predicted expiry time, then it's
This I
expired.
didn't. I mean, where is the anticipation? Here we create the anticipation task, right?
Yes.
And
Well,
the
actually, that's where
expired
we.
the
Yeah,
expired
it's there.
task occurrence time should be the one the prediction was based on.
Yes.
Right. This I mean. If, for example, the system anticipates the light to be on in 10 seconds and it doesn't happen, and it, for example, expires in 20 seconds, it should still recognize it as it didn't happen in 10 seconds. As the
Yes.
prediction claimed.
Yeah.
Right.
So where the anticipation task is added, it adds the expiry time at that point, so it will know.
But it should also add the occurrence time of the anticipation task. Because this occurrence time
that's the same
should
thing.
be
That's the same thing.
The expiry time is after the occurrence time of the prediction. The expiry time is, for example,
Oh,
10
sorry.
seconds
Yeah.
after.
Because we have to add in the bit about the window of. Yeah, you're right. Sorry. Yes.
Right.
Yeah. So it probably needs both of those things in that case. Yeah. Okay. Let me make a note of that. So
This should really
it's the predicted
have
plus expiry. Yeah.
should the occurrence time of the task which created the anticipation at first place.
Yeah.
Right.
Yeah, you're right. So because the occurrence time is the predicted time it's going to occur. Yeah. Right. And then the expiry time is that occurrence time plus the allowance we allow for it to be either side of that point. Yes. Okay. All right.
I have a question about anticipation. What if, for example, the event is on, and there are similarities between likes. For example, liked 1 is like a liked, like 2 is like a liked, and so on. Does it channelize the events?
Well, they'll be in different concepts. So each of those, if each of those is predicted to occur, they would have their own anticipation tasks in their relevant concepts. There's no connection between anticipation tasks in different concepts, if that's what you're asking. They are contained within a concept and never leave that concept.
So there's anticipation for each like, for example.
Yeah, each light would have its own anticipation task. Yeah. So there would be no way for light on to anticipate light 1 on. They're completely separate anticipations and they're not connected in any way from the anticipation perspective.
But can channel inference generalizes to other lights.
Yeah. I mean,
This,
there's no reason why that won't happen. I mean, you can light on and light one on. They obviously just normal inference rules apply, and they can be associated through inference. If it turns out that one of those predicts an event, then there will be an anticipation created for that. So it's not necessary for anticipations to cross between concepts, because the general inference can do that directly, and then the anticipations just need to be local to each concept.
I see. Thank you.
Okay. Roman and Jared, you had questions about anticipation. I don't know whether that's answered them or not.
I think I will have a lot of questions, but I really don't have any more energy for today. I really
Yeah,
need
it's
to
late
sleep.
for you, isn't it? It must be midnight your time.
Yes, it
Yeah.
is.
How about you, Jared?
Yeah, I'm all good.
You okay with that?
Yep.
Okay,
Oh,
cool.
sorry.
No, it's all right. We were just checking that there were no issues.
Oh,
I
okay.
think that was, in fact, the last box to talk about. Fortunately, because I think everyone's fallen asleep. Yeah, that was it.
Woo.
All right, guys, that's good. We identified some issues there, which were good, and some key ones, which is definitely worth doing. So good job to everybody involved then. If no one has any more questions, we'll wrap it up, and I will change the documentation to reflect our discussions. Any final points from anybody?
No.
Great work, guys, and Patrick, you're on your A game, finding those issues.
Thank you.
All right, guys,
Then
I'll say
then
good
have
night
a
then.
nice evening.
Good night.
Good night.
Good night.
Night.
Good night. Thank you.